Today the topic is 3D printing, and I'm going to show you how to install Klipper on your 3D printer using Docker in Windows and Linux step by step. I'm Leo, and this is my channel Leo Tech Lab. If you don't know it yet, take a look at the introduction video. Let's go. Okay, so first let's start with a disclaimer. This video is not a detailed explanation of how Klipper works, okay? There are already several videos and extensive documentation on that subject. So I'm going to assume that if you're here, you already know what Klipper is and how it works even in a basic capacity. Klipper is a system that only runs on Linux, and as such, the only option to run it on Windows is through virtualization technology. In this case, we'll use a Linux virtual machine on Windows to demonstrate both scenarios. If you're using Linux, just ignore the parts of the tutorial that refer to Windows, and the rest is the same for you. If you don't know how to install Docker on Linux, you can watch my video dedicated to the subject. The link will be in the description. If you're using Windows, it's assumed that you already have a Linux virtual machine with Docker already installed, connected directly to your home network and with USB pass-through capabilities, so that you can use your 3D printer and a webcam inside the Linux virtual machine. In my case, I'm going to use the VMware player, which is free for personal use, as a hypervisor. If you don't know how to install a Linux virtual machine with these features on Windows, you can watch my detailed videos on how to enhance your Windows server with a Linux virtual machine and how to install Docker on Windows with USB devices. The links will be in the video description. In these diagrams, I tried to summarize the main points without going into too much detail of the architectures of the two main 3D printing firmwares available today, Marlin and Klipper. Let's start with Marlin, which is the oldest and was until recently the standard. In the case of Marlin, its architecture is very simple. It has a single component, the firmware, which is installed and run directly from our printer board. Basically, the printer's processor takes care of everything, which is summarized and simplified in this diagram as two activities: thinking and working. The thinking part is all the processing that involves translating the G-code of the input file we want to print, which is the 3D printer program, into specific instructions for the working part. The working part interacts directly with all the actuator parts, like motors, sensors for temperatures, etc., to carry out the instructions of the thinking component. This means that we don't need anything else to start working. The printer is self-sufficient to print. We can simplify our life by installing a front end for our printer on a separate server computer, which is nothing more than a software that allows us to control our prints remotely and graphically through a browser, for example, which makes the process much more convenient. One of these front ends is Octoprint, of which I have already made videos about its installation on both Windows and Linux. Links will be in the description. Octoprint communicates via USB with the printer's Marlin firmware. So the Octoprint server will need to be physically connected via USB to the printer. From there, Octoprint exposes a graphical interface accessible via browser to any machine that has network access to it. In my opinion, and in summary, Marlin's main strength is its simplicity, especially when compared to Klipper. Now let's take a look at Klipper's architecture and how it compares to Marlin's. Basically, Klipper explicitly separates the thinking and working components. The thinking component is called the Klipper host, and the working part is the Klipper firmware. Each of these components runs on a separate processor. Klipper firmware runs on the printer's processor, just like Marlin, but Klipper host runs on another processor, which is much more powerful than the printer's, which gives Klipper better performance than Marlin on average. The second processor can be something that attaches to the printer, for example, in the form of a screen or tablet, that can also serve as the printer's front end. This is usually the case for printers that are already sold with Klipper or Marlin printers that have been converted to Klipper by purchasing the screen or tablet as a later upgrade. It is also possible to install the Klipper host on a computer or server, and in this case, physically separate from the printer. In these situations, the Klipper host is usually connected to the firmware via a USB cable between the computer and the printer. On top of the Klipper project, 3 other projects emerged that brought great versatility to the Klipper ecosystem, which are Moonraker, Fluid, and Mainsail. Basically, Moonraker allows the exposure of Klipper host's operations as an HTTP web services API. Before Moonraker came along, it was only possible for the machine's own processes to interact with the Klipper host via Unix sockets, all inside the same machine. Moonraker made it possible to invoke these same operations from any machine connected to the same network using a browser, for example. This made it possible to develop front-ends that consume these new web services exposed by Moonraker, and that's exactly what Fluid and Mainsail do. They are 2 graphical web front-ends that consume Moonraker's web APIs and allow us to interact directly with our Klipper host through a graphical UI in a browser. It should be noted that, although in the diagram the front-ends are represented on the same server as the Klipper host and Moonraker, given that the communication between the front-ends and Moonraker is done over the network, the front-ends can be hosted on a machine other than the server, although they are usually all on the same machine for simplicity's sake. Another thing regarding front-ends. There is also a way to use Octoprint with Klipper, but given that it wasn't a UI developed explicitly for Klipper, I won't use it in this tutorial. Let's start by connecting our webcam and 3D printer to our virtual machine permanently. You can see how to do this in detail in the USB pass-through section of my video on installing a Linux virtual machine on Windows. The link will be in the description. So I'm going to assume that you already know how to do it, so I'm going to just glance over it here, okay? So over here I have my virtual machine already running, and in the removable devices section I have my webcam connected and my 3D printer also connected, okay? They are permanently connected because I have edited the VMX file of my virtual machine, and I added a line for the auto connect for my 3D printer. So this was the previous line for the webcam, okay, device 0. This is the vendor ID 0C45 and the product ID 636D. This is for my webcam. What I did was I replicated this line, I added device 1 instead of device 0, and then I added the vendor ID 1A86 and the product ID 7523 to my 3D printer, okay? And if you recall, you can get these values of vendor ID and product ID from the ls-usb command. So let's connect to our virtual machine, which is connected to the printer, and let's ls-usb. And we have here the Kinhing Electronic CH340, okay? So we have the vendor ID 1A86, exactly this one, 1A86, and we have the product ID 7523, 7523, okay? So this is how you do it, just a quick reminder. If you are working directly on Linux, just connect the devices to the USB ports of your computer, and if you do the ls-usb, they will hopefully show up here. Quick warning regarding the USB connection of the 3D printer. I strongly recommend that you prevent power from passing through the USB cable, so that it does not interfere with the printer's electronics. I talk about this in more detail in the requirements section of my Octoprint installation videos. The links are in the video description. Let's also validate that we have the drivers loaded correctly on Linux for both the webcam and the 3D printer. Okay, so as in my other videos, you can use the lsusb command as we've done here. And here is the printer and here is the webcam. Now we can use the lsusb -t to see this in form of a tree, and this will also show us if they have the device driver correctly loaded or not. So for the webcam, it's in USB bus 3 device 3, so USB bus 3 device 3, it's these four over here, both video and audio, and all of them have the drivers correctly loaded. Driver equals UVC video, driver equals sound audio, okay? If they didn't, it would show up something like driver equals and then a blank space, okay? That means no device driver loaded. And for the printer, it's this one, the Kinghang Electronics CH340. It's on USB bus 3 device 6. USB bus 3 device 6, it's this one. And we have a loaded driver. Driver equals CH341, okay? This means that we can ls our /dev directory and see the files that correspond to our hardware devices, okay? In terms of the webcam, it's video 0, okay? And for 3D printers, they usually are either TTY USB 0 or TTY ACM 0, okay? For my printer, which is a Sovol SV06, it's TTY USB 0, which is up here. So everything is working properly. By the way, one more tip. If by any chance your printer is not being correctly detected, it may be due to an incompatibility with the Braille BRL-TTY package, okay? This sometimes prevents Linux from correctly loading the device driver for your 3D printer. At least I had this problem, okay? If so, try removing that package from your system with sudo apt remove BRL-TTY, okay? In my case, I don't have it installed. Package BRL-TTY is not installed, okay? But anyway, if in your case you do have this package installed and the printer is not loading the device driver correctly, try to remove it, restart your computer, and check if the printer now is correctly detected on Linux, okay? So we have the two devices connected, the device drivers are loaded, and the files are present in the /dev directory. Let's move on to the next step. There are several ways to install Klipper. My two favorites are using Kyahoo and Docker. Kyahoo, here is the website. Kyahoo is an open source script that helps us install and manage Klipper components, okay? I will leave a link to the website in the description. With this script, we basically have to compile the source code of the various Klipper components on our machine. Kyahoo takes care of the automation of this compiling process, okay? However, when trying to use Kyahoo on Ubuntu 24.04 LTS, which is the one that I'm currently using, the latest Ubuntu server version, I ran into C compiler issues. The compiler version and libraries that come with this version of Ubuntu do not allow successful compilation of Klipper using Kyahoo. I tested it with Ubuntu version 22.04.4 LTS, which was the previous long-term support version, which contains an older version of the C compiler and its libraries, and it worked without problems, confirming that this is indeed an incompatibility between the version of the C compiler libraries and the current version of the Klipper code. This is a major disadvantage of installation processes based on compiling source code. All it takes is one tool failing during the compilation process, and we have a hard time trying to figure out what went wrong, especially if we don't have software engineering skills. As such, I usually prefer the approach where pre-built executables are made available to end users. And this is exactly the common approach of Docker containers. A pre-made image ready to go, where you ensure that there are no variations of dependencies on the user's machine, as they all come pre-packaged in the Docker image itself. With that said, let's install Klipper using Docker. Before we begin the installation of Klipper, check that you don't have any programs or containers running that are using the webcam. If they are, end the program or stop the respective container. Okay, let's see. I do think I have a container running. Yeah, Ustreamer. This is from my last tutorial. So we should have access to the webcam at port 2345. 192.168.153.129.2345 stream, and yes, that's it. Okay, so we need to stop this. So cd host, same directory structure as the last tutorial on Docker, Ustreamer and Docker compose down. This will stop and destroy the container. Docker ps, and it's stopped. Okay, we are ready to start. I was able to discover an excellent repository on GitHub for Klipper features with Docker from a gentleman named Marcus Kuffner called Prind. Okay, and this is it. Prind. The link will be in the description. Okay, this gentleman is also the author of the Docker image for Ustreamer that I used in my Docker tutorial on Windows. Okay, Prind includes 2 Docker images made by Marcus for the Klipper host and Moonraker components. Okay, in addition to this, it also provides us with ready-made Docker Compose files to set up a complete Klipper environment with 3 web interfaces: Fluid, Mainsail, and Octoprint. Okay, in addition to other more advanced options that will not be covered in this tutorial, such as Klipper Screen, for example. Okay, we also have the option, here it is, to compile the firmware manually for our printer through a Docker image that already contains all the dependencies needed for the compilation. We'll talk about this later when we talk about flashing the firmware to our printer. In short, Marcus gives us everything we need ready to go. Fantastic. Thank you, Marcus. Now let's go ahead and use Prind to launch a Klipper environment on our computer consisting of the Klipper host, Moonraker for the APIs, and a web interface of our choice. Currently, you can't have several web interfaces at the same time with Prind, although technically it's possible to have multiple web interfaces at the same time. As I mentioned before, Octoprint can be used as the UI, but it wasn't explicitly developed for Klipper, unlike Fluid and Mainsail, so I won't use it in this tutorial. Let's start by launching our environment with Fluid, and then we'll launch the same environment with Mainsail. Okay? To do this, we need to have our printer's configuration file, which technically specifies all the printer's parameters. This file can be obtained from your printer manufacturer, possibly, or from your printer's online community. Okay? Klipper itself has in its source code repository, let's go to it, Klipper, the GitHub, here it is, in the config directory. So as I said, Klipper itself has here in its source code repository a predefined set of configuration files, okay, for hundreds of printers, which you can use as a basis to customize for your printer. Okay, so in this case, I'm going to use the configuration file from here, from the Klipper repository, for my own printer. So I'm going to search for Sovel SV06, Creality, Soval SVO6 plus, no, mine is the standard. Soval SVO6. It's this one. Okay, it even has instructions on how to build the firmware, but we'll get to that later. Let's download the file. It must be harmful. No, keep it. I trust it. And here you go. Here's my configuration file for my printer. Okay. Okay. Now that I've downloaded the config file, let's launch our Klipper environment with Fluid, okay? And for that, we just have to follow the instructions on print. Let's do that. Here it is. So, configuring Klipper Moonraker. First of all, we need to clone this repository. Well, you don't need to, but for me it's easier, okay? Because it does bring you all the Docker Compose files immediately. So let's do that. Copy this URL over here to clone this repository to your server. Oh, by the way, if you don't have Git yet, sudo apt install git, not gr, git. Okay. And now with git, you will do git clone and then paste in that URL, that one. Enter, and it will clone the repository to your server. Done. So now we have a print directory, and inside it, we have a copy of these files and directories over here. Here they are. Now we can go ahead and follow the instructions. Starting the stack. There are currently 3 front-end profiles. We want Fluid. Starting the stack comes down to inputting Docker composed -- profile and the profile name up -d for running in the background. So let's do that. Okay, so let's go ahead and launch it. Docker compose, following the instructions over here. -- profile Fluid up -d, enter, and it will download and launch the containers. And here we go. Okay, so we have several of them running. Let's do a Docker PS and look at them. Okay, so now we have Klipper host here. We have Moonraker on top of Klipper host, exposing the APIs, the web APIs. We have the UStreamer. Okay, this is the webcam part. We have our Fluid web interface as well, and traffic is just a reverse proxy. Okay, so it's just mediating traffic so that we can access all of it from port 80. Okay, so this is just for simplicity reasons in terms of networking. Okay, so don't worry much about it. But we have all the components running. That means we can now access the port 80 Fluid. Okay, port 80. So we can go to 192.168.153.129, and port 80, we don't need to specify it because it's the default port. Just press enter, and we should have the Fluid web interface with our webcam. Okay, the printer is not yet working because we need to copy our printer configuration file into the Klipper host. Okay, so let's do that. In our configuration section here, we can upload our file, the one we downloaded from Klipper, this one. Let's upload it to our container, and now we can rename it so that Klipper can find it. Let's rename this one to Klipper old, and let's rename our new configuration file. Oops, I don't want to edit it, I want to rename it. Let's rename it to printer.config and restart Klipper, and we should have yep, and we have connection to our printer. We now can see the extruder temperature, the heated bed. we now have access to our printer commands. Okay, homing. Perfect. Now I have to point out here that we are in luck because it wasn't supposed to work right out of the gate at the first try. Oh, and by the way, this is working because my printer is already flashed with the Klipper firmware. Okay, but we will see how to do it in the next section. But other than that, in the printer config, I was lucky enough because here this line serial, this indicates the file descriptor that points to my specific printer. And in this case, I was lucky enough for this file descriptor to be the exact same. And to see that, you will have to ls the /dev. Okay, this one over here, /dev/serial/by ID directory. And you can see this here is the identifier of my current printer. Okay. If in your case it is different from the one that is present on the config file, you need to delete this and then put the correct one in so that you can enable communication to your printer. Okay. In my case, it was already done. For me, it was the same. But if it's not the same, just delete the one that is present, paste your current one there, save the file and just press restart Klipper, and you will just be able to successfully connect to your Klipper printer. Okay. This, of course, assuming you already have the firmware flashed onto your printer. Okay, so that's it. We have Klipper up and running on our server. We now need to install the firmware on our printer, okay, to complete the process. And in the end, we'll do the test for both web interfaces, Fluid and Mainsail. If you already have your printer flashed with the Klipper firmware, you can move on to the final test step. If you still have Marlin firmware on your printer, you need to first flash the Klipper firmware on it so that the Klipper host can talk to it. This process will vary from printer to printer due to differences in the internal hardware of the printer, and it usually involves you compiling the firmware for your printer. However, most likely someone has already done the work and shared the firmware ready to be flashed. In my case, with my Sovol SV06, this is exactly the case. You can go ahead and move on to the next step if that's your case as well. But just in case you don't have the firmware provided, let's go through the manual process of creating the firmware step by step. To do this, we can use print, which provides us with a Docker image that already contains all the dependencies necessary for the firmware compilation. Regarding the specific firmware settings, it varies from printer to printer. Once again, I recommend using an online community for your printer, but in my case, the Klipper configuration file for my printer has the detailed instructions I should use to compile the firmware. Okay, so if we go to the file that I downloaded earlier, my configuration file, here on the top, we have specific instructions on how to configure the firmware creation process, okay? So the board and processor, the bootloader, the serial that we should use, and also this disable SWD at startup option, okay? Once again, if you don't have these instructions, go ahead and interact with your online community for your printer. I'm sure they will help you out. So let's do this. Oh, by the way, this is another important aspect. I'm currently using shared folders, okay, from my previous tutorials. So these folders are shared with the host, with Windows. I can come here to see VMs shared. And these directories here, print, Ustream. So this print directory here is exactly the same as this one, okay? But unfortunately, this means that symbolic links when using these kinds of shares inside virtualization technology, they may not work properly, okay? And unfortunately, that is the case here. So, given that the process of the firmware compilation does require the use of symbolic links, we need to have this in a directory that is not shared with the host, okay? So what do I recommend in this case? Clone the print repository again to a non-shared directory, given that you can just delete that directory afterwards, because you will only do this firmware compilation process once. After that, you don't need to do it again. Only if Klipper updates itself later on will you be required to recompile your firmware, okay? But even then, you can just recreate this process easily. So let's go over to our home root and let's clone the print repository again here. So git clone and let's copy this. So same thing. The only thing is that this directory here, this print directory, is not shared with our Windows host. So we can use symbolic links. Now, let's go over to print and follow the instructions to build the MCU code. So first, he's telling us to make an alias of the make command. So alias is just a shortcut, okay? So when we write make, we are actually inputting all of these commands. And don't worry that this is temporary. Every time you reboot your Linux machine, the aliases will be gone. So let's just copy it, enter, okay. Now let's confirm that the alias is present by inputting only alias. And here it is. Okay, so we have the alias for the make command. Next, make menu config. Okay, and now we have to input our configurations. Let's enable the extra low-level configuration options just to have the full option spectrum. Okay, and I'm going to open my configuration file which has these instructions. So let's go. So first off, the microcontroller architecture. It's the STM32F103, so it's the STM32 architecture. And the processor model is the STM32F103, and it's exactly that. Okay, perfect. It's this one. I don't see anything talking about this option. Next option, disable at startup. Okay, that one, it's saying here to select it. Since it is using the blah, 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 please select disable SWD at startup. So disable SWD at startup, okay. Bootloader offset, 28K. So it's not this one, it's 28K, perfect. Clock reference, here it doesn't say anything about that, so let's move on. Communication interface, okay. Here it's the serial USART 1 PA10 PA9, serial USART 1 PA10 PA9, it's this one. Baud rate for serial port, it doesn't say anything, so I'm going to leave that. And GPIO pins, doesn't say anything for that as well. Okay, so this is done. Let's escape. And now save configuration. Yes. Okay, done. So it has saved the configuration. And now the next step is to compile the firmware. So let's just input make, and it will compile the firmware for us using this configuration that we've just configured, so to speak. And we have an output file, the clipper.bin file. This is our firmware file, okay? So now how do I get this file? Well, for us it's easy because we do have shared folders. So we can just point it to here for the root, for example. Okay, next to the test.txt file, we can put it here. So we can just well, first of all, where is it? It's on the out directory. It's here. So let's just copy this file onto the shared directory. So let's copy cp out /clipper bin to home directory /host/shared. There you go. And now we should have that file over here. Here it is. Okay, so this is the file that we're going to put on the root of our SD card, and then put the SD card on the printer and flash it. Okay, but what happens if you don't have shared folders in your setup? You can just use SFTP, for example. Okay, if you're using SSH as I'm using, SFTP uses the same port. Okay, uses port 22, and you can use that to transfer this file out of your virtual machine. Okay, but for us, we don't need to do that. We just use the shared folders feature, which is very good. And now we can do a little bit of cleanup and remove this print directory that we just used for the firmware creation. We don't need it anymore. So we can just sudo rm. So remove -rf. So remove everything, including all subdirectories from print. And that's it. It's gone. We have our firmware created, and we have our previous print directory still intact. Perfect. To flash the firmware file on your printer, you can use a direct USB connection with your computer or an SD card. Personally, I prefer the SD card method, so that's the one I'm going to do. Let's take our firmware file, put it in the root of the SD card, and give it a name that hasn't been used in the past for the flash. Okay, so let's go ahead and do that. This is my SD card, the Sovel SV06. It's empty, so let's go to the directory where we left our firmware file, shared, Klipper bin. It's this one. Copy and just paste it in. Okay, make sure that you're using FAT32 for your file system. Okay, if not, just format it to file 32 on your SD card for compatibility reasons. And just make sure that this name, clipper.bin, hasn't been used in the past. Okay, you can use a counter like clipper1.bin, clipper2.bin, clipper3.bin, for example. This mechanism of saving previous names is used to ensure that when you restart the printer, even if the firmware file is still in the SD card, it is not reflashed by accident each time you turn on the printer. Okay? Either way, I always recommend deleting the firmware file from the SD card as soon as the flash is finished. Okay? So, to begin the flashing process, just turn off your printer, put the SD card in the printer, turn on the printer, and wait for about 20 to 30 seconds, okay? The process usually takes around 10 seconds, but I like to give it more time just to make sure it works properly. After this, just turn off the printer, remove the SD card, and delete the firmware file that was inside. There may be no visual feedback on the printer display that the flashing process has finished, okay? For example, on my Sovel SV06, there isn't any kind of visual feedback that the flashing is done, okay? So what do you do in that case? You basically just turn off the printer after the flash, turn the printer back on, and go ahead and test with our Klipper fluid interface that everything is working properly. To confirm that the flash was successful, we need to connect our printer to our computer that has Klipper running and see if the Klipper host can communicate with the firmware. So let's go to our Fluid UI to see if the Klipper host can communicate with the printer's firmware. Okay, let's refresh this, and yes, we can, because of course we already knew that. But here you see you have the extruder working, the heated bed working, you have the webcam as well, and you have all the printer controls active as well. You can issue commands through the console. Everything seems to be working. Okay, so in this case everything is okay. If not, the flash probably went wrong or didn't flash at all due to the file name protection I described earlier. Okay, so in that case, try changing the file name. Okay, like for example, adding that counter, Klipper1.bin, Klipper2.bin, Klipper3.bin, etc. Try changing the file name and flashing again. Okay. By the way, another way of checking connection between your printer and your Klipper host is, at least for my printer, it works like this. When the Klipper host is active, your printer screen will show up and will show data on it, okay? Temperatures, etc. When the Klipper host is down, it's just a blank screen. With your printer, it may be different, but at least in my printer, it works like this, okay? And it was previously a Marlin printer. So, assuming everything is working with Fluid, which it is, let's now test mainsail as well, so you can see the other web interface, okay? And to do this, simply follow the documentation of print. So let's do that. Let's go over here and see how we can. Okay, it's over here. So we need to shut down the Fluid profile and turn on the mainsail profile. So let's do that. Let's shut down the Fluid profile with this docker compose command. Let's just paste this. So docker compose -- profile Fluid down. Okay. Do not forget to issue this command inside the print directory, which has the docker compose files. Let's press enter, and it will stop and destroy all the containers that are related to this Fluid profile. Okay. Meaning the Klipper host, Moonraker API, traffic reverse proxy, the Ustreamer webcam, and Fluid itself. Okay, it's done. So currently, if I try to access Fluid, I should get nothing. Yep, it's gone. Now let's go on and get mainsail up and running. So we just need to do docker compose -- profile mainsail up -t, enter, and it will launch exactly the same setup, but this time instead of launching Fluid, it will launch mainsail. The rest is the same. Perfect, it's working. So now if we go over here and we just refresh this page, we should have, oops, okay, we have a caching problem. So let's just Control F5 to force a cache refresh, and we should have, perfect, mainsail. And here it is. So everything is working. Okay, it's the exact same file, the same printer configuration file. So it's everything is working as expected. We have extruder temperature, heated bed temperature. We have the console here. We have the webcam as well, and we also have the toolhead commands. Perfect, everything is working. It's just a different web interface. Okay, the printer config is exactly the same. Okay, because this file is outside of the container, so you can create and destroy containers as much as you like. These files are outside of the container file system. Okay, they are over here in the config directory. It's this one. Okay, so these files are outside of the container file system. This allows us to just destroy containers and lift containers back up whenever we want. We won't have any problems in losing our configuration. Okay, perfect. And that's it. So we have a full Klipper system running in Docker that works in both Windows and Linux. By the way, if you want to update this, imagine that there is a new version of Mainsail or Fluid or Klipper host or whatever. If you want to update your setup, it's really easy to do because we are using Docker containers, which are awesome. Okay, so check this out. Let's imagine that we have updates. Okay, and how do we do this? We just come over here. Let's compose. Let's use the Docker composed mainsail down. Okay, so let's destroy our current setup. Okay, but the config files are safely tucked away in the Linux file system, not in the container file system, so that's not an issue. Now we can do Docker compose pool on our profile. So if we want mainsail, we will say Docker compose -- profile mainsail pool. This will basically tell Docker, just go ahead and check to see if there are any updated images on this profile. Okay, if there are, get them for me, the new images. Okay, after that we just do Docker compose profile mainsail up. So let's get back up again, and this time Docker will use the most recent images in order to create the containers. It's done, and now we just refresh our web interface and it's done. And that's how you update your Klipper setup using Docker. Really, really simple. Okay, all the configuration files are safely tucked away in our Linux file system, so none of them gets destroyed when we destroy all the Docker containers. And that's how we can easily update our entire setup. This tutorial is done. And that's it. I hope it was useful to you. Please leave your feedback and share your ideas and opinions in the comments. And if you want to stay up to date with the next videos, you can subscribe to the channel and click the like button. Thank you, and I'll see you next time.